Welcome to another problem session. We are doing this for MCAT and JEE prep. Okay, so we are doing this. We are going to be doing this for quite some time because it covers a lot of ground. So right now we're on F equals MA problems, and we did a couple of problems, inertial versus non-inertial frames. So there are some classic problems people ask, and they're really relatively easy to solve. And so it's important to know them for the test. So here is a here is a classic problem. So a box sits on the bed of a truck, and the truck is accelerating with respect to the ground. So that this is with respect to ground. Acceleration is that way. At some point of the value of a, the box will start to slide. And the question is, what is that point? All right, and how do we find it? So this is for a small, what value of a? So there's a value if you, of course, it's at rest. If a is 0 and no acceleration is constant speed, a is not sliding. But when you accelerate, maybe not sliding yet, but if you keep increasing the acceleration, eventually there comes a point it's going to slide, and that's the point we want. After that, it's not a question. It doesn't address after what happens after that. Okay, so we're trying to find a critical A. So this A is a critical A. Okay, another related problem. I hope we have time to do it today. If not, I'm going to do another day. I'll just add two of these problems in the same video, one after another. And this is a problem, say same truck, but instead of box. You put a pole here, and you put a pendulum, this string, and here's a mass. You put a pendulum, and of course, initially the pendulum is down here, but as truck goes, maybe the pendulum is here or here. So I'm not going to tell you a pendulum is here or this kind of angle theta. It's not going to swing back and forth. Okay. If a is a particular value, that value, say I give you an A, I accelerated A, then I find that the pendulum comes and remains at rest. Here, I mean, what do you mean at rest? It doesn't swing, okay? It doesn't swing back. It just, as if like the whole thing is just either it's swung back that way and being dragged, I swung forward like that, and you got to figure that one out. Maybe you have some intuition, you can figure that out. Or you can do it algebraically. Either it's this way or this way, and then what is the angle of that? Okay. Now let's do one first, and then see if I have time to do two. All right, so go ahead, do one, and then see if we can get the answer. So doing the one, I have a choice doing in an inertial frame. In this frame, it will be F will be mass times acceleration for the box. So this is the box. And in a non-inertial frame, so this will be frame tied to ground. And this will be frame tied to truck. So this is accelerating. In this frame, and truck was accelerating at A. So this will be, I need to add fictitious force of little m minus little m A. So the F gets modified by this, and this, this A is not the same as that A, and if you want to make sure, you just call it that. So that's the equation of motion in non-inertial, and this is the equation of inertial. We can do it either way. Let's do the inertial one first, because we are kind of used to it. So I need to find frame, and so here's a bed of the truck, and I'm going to just use a frame. Just use a frame which is out in the space at the same level at the center of mass of this thing. So what are the forces on? I'm going to get a force. So writing the equation motion. So with respect to this frame, this thing is not sliding. So this guy's acceleration is also A. Whatever this A is, over here, whatever this A is, the entire thing has A, because this is not sliding. So the entire thing is A. Every part of it has acceleration A. So the box is also, so looking at just the box, so I'm just going to look at the box. And so it will be mg of the box, normal on the box from the bed truck, so normal by truck. And then there's no forces there, so how do you explain this acceleration? Well, there will be a static friction. So that is the important part, because acceleration is that way, there has to be static friction that way. And I want a critical value. That means I want this to be a max amount of max that can support it, right? So now this will be equal to, in magnitude, mu s n, this n. So this is what you know from solving a whole bunch of problems like this, right? Now, so this is very simple. So along the x, this is the y-axis. This is the x-axis. So along x, along y is just n minus mg equal to 0, no acceleration. This acceleration is all x direction. And so Fs max and so I'm using this. So this is 1 and 2 and this is 3. Put them all together, you're going to get n equals mg, and so Fs max will be a static coefficient of friction between in that surface, times n is mu s using this mg, and plug in there, that gives mu s mg equals to ma. So m cancels out. So when a is mu s g, that's the value we want. That's the answer. At that value of a, it starts to slide. So at this value of a, box will start to slide. And when it starts to slide, you have a kinetic friction and you have all the other things we can do with it, right? How about if we do it this way? We should get the same answer. But so here's a truck, and this is the Y, and you have X, and we just make it prime so that we are dealing with a different. So this is kind of like it's like that. All right, so but this is the only thing we're concerned with. So now with this prime, this guy's acceleration is 0 because the frame and this moving together. Velocity is 0, acceleration is 0. I could even put this frame right on top over here. So why not we do that? Simplify this space gap, don't need that. We can just put right there. It's attached to the bed, but going right through this thing. So this is Y prime. So let's look at the forces. It's the same forces over there. Force is the same. This and this, same F. So I already did the work over there. I already did work over there. I should do work over there. So I will have N and Fs max. But the equation motion here is this. So along the x prime axis, I'm going to get Fs max, then minus M A. So this is not this A, but this A of the frame with respect to the non-cell frame. So this is A is acceleration of the O prime frame with respect to inertial frame. Not that of our system, which is box. So box is that. So this is coming from the left side, and this right side is 0, acceleration 0. So this is mass A prime equals mass times 0 is 0. Just 0 vector or 0. We're looking at just x components, x 0 is 0. And of course Fs max mu s n, and if you look at a y prime, it still is n minus mg equals 0. So these again are going to give you A is equal to mu s g. Same answer. All right. Let's see. I'm going to stop this video and then I'm going to come back and try to do the other one because I think I have time. We can do this problem, pendulum fixed to the bed. It's going to be this way or this way, and I'm not going to prejudge it. Suppose I didn't think about inertia and all kind of things, and it wasn't guessing around. Answer should come from just applying F equals ma, right? That's our kind of process. So let's do this out. All right, so I'm going to redraw it. So we have either this, I'm going to draw it like this. This side will be positive theta. if theta is positive, this side, if theta is less than 0, it's going to come out. To start with positive, just our picture, okay? So this is where it's fixed, but I'm going to do a frame, inertial frame. So this is going to be inertial. And I'm just going to, this will be my x-axis, and this is y-axis, and this is O. And of course, this point is moving with the truck, right? This is the acceleration A. So this point, let's call this distance, let's call it x. And this guy, so the x, so x will depend on time. And so this point, suspension point, v of t will be dx dt, and its acceleration of t, we are just looking at the x component will be dvx dt, or d square x dt square. So that's the suspension part. We need this, our system, let's call it is current x and y, this at time t. So from here to here is x, let's call it L. So we have a constraint here. We have x equals to big X plus L times this much, which is same as this much. And in this triangle, this will be sine. Of course, the y is, that's the y, and y is negative here. So y is negative L cosine theta. So this should give us the, take a derivative, one derivative, Vx equals to big Vx. And because at this time t onward, you know, this is not swinging. So if you were to not swinging, that will be 0. Vy will be 0. And a sub x will be a sub x. And we assume that this is the direction in the acceleration of the truck. So this is just a, and a sub y was 0. Now we can write the equation in this frame by identifying the forces. So what's the force on this? Well, one will be is weight, and one will be tension in the string. And this theta is same as that theta. So force along the x direction is minus t sine theta. Force on the y direction is t cosine theta minus mg. All right, so this force must equal to mass times the acceleration. So that's equal to mass times ax, but ax is a, mass times capital A, and this should be mass times ay, that should be mass times 0 is 0. So now we can solve this for t and plug in there, or you can just say need to get rid of t because we're only interested in the theta, right? So if you isolate t cosine theta, it becomes mg. So you have equation 1, equation 2. So if I divide 1 by 2, so minus t sine theta divided by t cosine theta. On the other side, ma over mg, m cancelled out and t cancelled out. This minus tangent theta equals A by G. So it turns out theta is minus arc tangent inverse A over G. And this is positive, and this is less than 0, which tells me not this way, but is going to be over here. If the acceleration of the suspension point is that way. So this is where the actual position. Okay, so that's the answer using inertial. How about we do it non-inertial frame? So in the inertial, you had F equals to ma, but in an so this is inertial. So the second law in the inertial frame. Doing the same thing in the non-inertial frame. So how they're gonna, so non-inertial frame will maybe attach to the suspension point itself. So I'm gonna again, I'm gonna just not pretend I know that, because I don't need to know that particular point, right? I don't need to know that point. It's already solved. I'm restarting the solution in a non-inertial. This is how I do it. So this is suspension point. That's going to be my O prime, and this is L. Let's call it theta prime. Let's call it X prime, Y prime. Okay, so, and suspension point has acceleration A with respect to insert frame. But of course, this frame is acceleration 0, right? So the equation is not this. Equation is the same F, but I need to add the fictitious force, mass of my system times acceleration of frame, and then it's going to be mass times A prime, acceleration within this frame. And which acceleration in this frame is 0, because it's just suspended there or here, one of these places is just suspended. So this is given as a condition for us. So this is equal to 0. So we already is F, just look at X prime part, X prime is same. It's going to be minus T sine theta prime. It's going to be the same way. Geometry is set up same way. So everything is going to come out same. Plus minus MA, AX is same as A because of the way it's all set up. MA equal to 0, so this is a plus. Yeah, that's the fictitious force, the negative of that. And Y prime is going to be the same force here, T cosine theta prime minus mg, but this gives me 0. Now this equation same, so this also does the same way, and you're going to have a tangent theta prime goes to minus A over G, which is the same answer. So theta prime is minus arctangent inverse A over G. It's the same answer. So theta prime is theta in both, So whether you observe sitting on the bed frame, say you are you have this truck, and you're observing from here. You say, hey, this thing is going with A, and so you see that theta, and if you observe from here, person A and say P and Q, person Q, both of them is the same. They observe, they see the pendulums on the same distance, same angle, okay, while the truck is accelerating at A. It's consistent observation, right? So just I think this is all I'm going to do as far as the inertial versus non-inertial frame problems are concerned. And just wanted to little bit of advertisement for my channel. So try to subscribe to this channel. And if you like this kind of stuff, definitely hit the like button. I do notice that. And if you comment, I sometimes able to explain things if I have time. You can tell your friends. I think this is the best recommendation comes from people who actually use it and benefit from it. So I appreciate your recommendations. Okay, so that's it. I'll see you in the next video. Bye.